In this question, the 3 points A, B and C are shown in the diagram. The perpendicular from C to AB, that's important. The perpendicular from C to AB meets AB at the point D. Find the equation of CD. This is quite easy one, because the thing is that they have given us this condition. We know that whenever two lines are perpendicular to each other, so we have the product of their gradients should be equals to -1. So we will find the gradient of this line AB, because we cannot find the gradient of the line CD because we are missing with the one coordinates over here. If we know that, we could have done it directly, because the required thing is to find the equation of CD. Whenever we want to form an equation, what we actually need, we need a coordinate and the gradient, right? So here we have been given, we are not given, but we can find the first gradient of this line AB, and we will convert the gradient of this line AB into CD, because they both are perpendicular to each other. So let's do it. First, finding the gradient of AB, that will be 11 minus 3 upon 13 minus 1, that will be 8 upon 12 is equals to 2 upon 3. I know that if I want to find the gradient of this line CD, I would just write -1 upon m of AB. So this will become -1 upon 2 upon 3, which is equals to -3 upon 2. That's it. Now what we want to do, we'll just substitute the value in it, and we'll find your answer for the equation of CD. For finding the equation of CD, we know the general equation y minus y1 is equals to m into x minus x1. The one part that is, either we could use the part for D, the coordinates, but we don't have it here, so I am going to use this one. So it's up to you. You can find, or you can use any point. It should be on the line, that's it. So I'll be using this point C. So y minus 15 is equals to -3 upon 2 into x minus 6, and upon simplification it will give you answer 3x plus 2y is equals to 48. That's the required equation of CD. Now let's talk about how to find the coordinates of D. For finding the coordinates of D, what we need to do, as you could see, the line AB is intersecting with the line CD. So whenever two lines intersect with each other, so we can find the point of intersection by just solving them simultaneously. The equation of line AB, we can find it out. What we need to do to find the equation of AB, we need gradient first. Gradient of AB, we have already found it, that is 2 upon 3. And any one coordinate, it's up to you. I would take this of A, which is 1 comma 3. So my equation will become y minus 3 is equals to 2 upon 3 x minus 1. So my equation is 3y minus 2x is equals to 7. So now just solve these two equations simultaneously and you'll find the coordinate. So comparing these two equations, finding the value of y from one equation. This is the equation of AB, so I'm trying to find 7 plus 2x upon 3. I will just substitute this into this equation. So this equation will become 3x plus 2, 7 plus 2x upon 3 is equals to 48. And upon solving, I get the value of x equals to 10. Once I get this value of x equals to 10, I will just substitute it back into the equation. I got my y value, which would be equals to 9. So that's how you find the coordinates of D. And this was the part 2. This was part 1. Alright, let's move on to the next question. Alright, in this question, the curve y equals to 9 minus 6 upon x and the line y plus x equals to 8 intersect at 2 points. Find the coordinates of the 2 points. This question seems pretty simple because a line and the curve is intersecting with each other, and we just have to look for the point of intersection. We know the method. We just simplify them by just substituting them equals to each other, or finding the value of y from one equation and substituting it back into the next equation. That's how we do it. It's pretty simple. So I'm going to just equate these two equations with each other. So y equals to 9 minus 6 upon 8 minus x will be equals to 9 minus 6 upon x, and we'll start solving it by taking 8 minus x is equals to 9x minus 6 upon x. Then 8x minus x square is equals to 9x minus 6. We have already converted our equation into a quadratic one. X squared plus x minus 6 is equals to 0. Factorizing it accordingly, plus 3x minus 2x minus 6 is equals to 0. Then x plus 3 into x minus 2 is equals to 0. And the x values are x equals to minus 3 or x equals to 2. Now substituting, first we should have written here how we actually converted this equation, or how do we find the value of y out of it. So y equals to 8 minus x, then 9 substituted over here, y equals to 8 minus x in it. Alright, so once we have found the values of x out of it, now I'm going to substitute this x values in the y equation, and we find 8 minus 3. Alright, so when x is equals to 2, y is equals to 8 minus 2, y is equals to 6. So we can write these coordinates like this: minus 3 comma 11 and 2 comma 6. So these are the x and y values when this line and the curve intersect with each other, so they would be definitely meeting at those points. Alright, in the next question, the equation of the perpendicular bisector of the line joining the 2 points. So we have to find the equation of perpendicular bisector of the line joining the 2 points. So these are the 2 points that I am going to write on the next page. Let's say these are the points A and B. So we have to find the equation of the perpendicular bisector. So let's suppose this is A and B, and there is a perpendicular bisector that is cutting this line. So minus 3 comma 11 and 2 comma 6. The step for finding the equation for the perpendicular bisector is first to find the midpoint, and that's how we gonna do it. Let's say this midpoint is C, right? This is C midpoint. So C x comma y will be minus 3 plus 2 upon 2 comma 11 plus 6 upon 2, and this will give you minus 1 upon 2 and 17 upon 2. So these are the midpoint that we have already found. Now what we need to find, we need to find the gradient of this line. And how are we going to do it? We know just one thing, that this line, this perpendicular bisector is bisecting this. This is perpendicular to this one. So what I'm going to do, I will first find the gradient of this AB and will convert the gradient of AB into CD by applying the perpendicular condition that we have studied previously. So gradient of line AB will be 6 minus 11 upon 2 minus minus 3 will be minus 5 upon 5 equals to minus 1. So if the gradient of line AB is minus 1, then the gradient of this line, let's say this is line CD, so CD will be minus 1 upon m of AB, which is minus 1 upon minus 1, and it will be 1 only, plus 1. Alright, now we have found the gradient of line AB, that is 1, and the coordinate of C, that is minus 1 upon 2 and 17 upon 2. So I will just substitute it back into my equation. Y minus y1 equals to m into x minus x1. So y minus 17 upon 2 is equals to 1, and x minus minus 1 upon 2. So finally I'll get this equation, y minus x is equals to 9. So that's how we actually find the equation of perpendicular bisector when you've been given with just 2 points, and you could apply this method for finding. This is most often tested in exams, so you need to concentrate over it. Alright, move on to the next one. In this question, the curve y square is equals to 12x and the line intersecting at 2 points. So this is pretty simple. Whenever a line and the curve intersect with each other, and you have to find the distance between the 2 points. So for finding the distance between the 2 points, first we should know what are the coordinates where they are meeting. First we'll find those coordinates, and then we will apply the distance formula, and we are done. Alright, so first convert this equation, make y the subject. So this equation will become 4 upon 3 x plus 6 upon 3, which will be y equals to 4 upon 3 x plus 2. Now I'll just substitute this equation into this curve, that's it. So 4x plus 6 upon 3 whole square is equals to 12x. Now upon simplification you will get 4x square minus 15x plus 9 is equals to 0. Then obviously you have to apply the middle term breaking or the factorization method, or either you could use quadratic formula or completing the square method. It's all up to you. I would suggest or prefer to use middle term breaking here, and you can see how I actually taught middle term breaking in the previous videos. You could see over there. So 4x minus 3 into x minus 3 will be the roots, and I will substitute equals to 0, finding the value of x out of it, and x equals to 3 upon 4. Now we have found the value of x 3. Now we have to find the value of y out of it. So the value of y will be, for when x is equals to 3, so I'm going to substitute 3 over here. So y equals to 4, 3 plus 6 upon 3 will be 6 only. So I will write this coordinate like this: x comma y is equals to 3 comma 6. That's very important. Sometimes students make so many mistakes, like substituting the value of x from some other coordinate and then meeting it up with some other coordinate. So definitely it would make a big mistake. So you need to be cautious while doing this. Now the next, when y is equals to, when x is equals to 3 upon 4, substituting again in it, 4, 3 upon 4 plus 6 upon 3, 4 with the 4 gone, 9 upon 3, which is 3. Alright, the other coordinates that we have is 3 comma 4 comma 3. Now we have to find the distance between these 2 points. So just apply the distance formula for finding. Let's say this is A and this is B. So just apply the distance formula in between them. So the distance of AB will be root 3 minus 3 upon 4 whole square plus 6 minus 3 whole square. AB will be equals to 81 upon 16 plus 9, which will be equals to 15 upon 4, 3.75 units. And that's it. That's how we find the distance between the 2 points.